All right. So everything we will do for about the next 2 weeks is going to deal with systems of equations. Okay? Linear systems is the majority of it. We'll talk a little bit about linear system or linear inequalities or system of linear inequalities, but for the most part it's linear systems. Okay? A system of two linear equation basically consists of two variables in two equations. So two variables in two equations. You're accustomed to seeing this, or you will be accustomed to seeing this as x and y. Okay? A solution to the system is going to be an ordered pair, again, normally x and y, that satisfies both equations. So what does it mean that it satisfies both equations? That means if you plug a number into the system, then it better work in both equations. So like on example 1, it says, is 0, 2 a solution to the system? So where x is 0 and y is 2, then it better work in each equation that I'm given. So if I have 2x plus 5y equal to 10, I'm going to go 2 times 0 plus 5 times 2. Does that equal 10? Yeah. So the whole left side is 10 equal to 10. That's good. Now, that doesn't mean, you bet, it works. Okay? It works for one line. It has to work for both lines. Basically what you're trying to do, or what we're trying to do, is to figure out where our two lines intersect. Okay, so then if I have x or negative x plus 3y equal to negative 6, I'm just going to have negative, and then I'm going to plug in 0 plus 3 times 2 equals negative 6. Is this going to be true? What's the left side going to come up to? What's negative? If I change the sign of 0, what is it? Still 0. What's 3 times 2? 6. So is 6 equal to negative 6? No. So is 0, 2 a solution? Did it satisfy both equations? No, it did not. Okay. So 0, 2 is not a solution. Okay, because it does not work right here. It's okay there. That's great. It's on that line. 0, 2 is a part of your line of 2x plus 5y equal to 10. Okay, if we turned it into slope-intercept form and we would graph this, 0, 2 would be on our line. But it's not going to be on our line of negative x plus 3y equal to negative 6. Okay? It has to be on both lines. For it to be on both lines, that's going to be where it intersects. So then whenever we graph it, okay, which is everything that we're doing today, is you're going to solve the system by graphing. Get it into slope-intercept form. That's going to be the easiest thing to do. So is the first one in slope-intercept form? Yeah. So I have y equals negative 2/3 x plus 4. So I don't have to change anything here. Where am I going to start my point, or where am I going to start my graph? At where? 4. From there, where am I going to go? Down to over 3. I'm going to do it again. And I usually just do it until I basically run out of room. And then just connect my points. Now, what I would suggest is running that line. Don't just find 2 points and just connect the dots and go. Run a line all the way across the graph, because you don't know where my other equation is going to fall. Okay, so what I would suggest, or what I would tell you to do, is basically run that line all the way across and even off the graph. That's okay. It's not going to hurt to run everything from one end to the other. Now, for the second one, where it's 4x plus 3y equal to 6, it's not as simple as, hey, we have a specific point, so we need to, or it's not in slope-intercept form, so I need to get it into slope-intercept form. So if I have 4x plus 3y equal to 6, how am I going to get it into slope-intercept form? What do I need to do to get it to y equals mx plus b? Subtract 4x. So I have 3y equals negative 4x plus 6. Now what? Divide by 3. So I'm going to have y equals negative 4/3 x plus 2. So then, now, where am I going to start? Start at 2. From there, I'm going to go down 4 over 3. I can also go up 4, 1, 2, 3, 4, and back 3 if needed. Down 4, over 3. And then again, I'm going to find something that is a straight edge. And connect my points. So where does everything run through? So what's my solution? 6, negative 3? Negative 3, 6. There you go. Remember, we always go with our x value first. So negative 3, positive 6. How do I know that that's right? Plug in the numbers. Okay? There is never a time that you should ever be wrong here. If you're wrong, then you're just too lazy to check it, to be perfectly blunt and honest with you. Okay? Because you have a solution of negative 3 and positive 6, you can take it just like we did before with the 2 or the 0 and the 2 and plug it back in to see if it's going to work. Okay? Again, it has to work in both equations. It has to work in the y equals negative 2/3 x plus 4, and it has to work in the 4x plus 3y equal to 6. Okay? It can't just work in one, because at some point you may graph it wrong. You may have started at a negative 4 or a negative 2. You may have changed the sign. You may have messed something up somewhere. And that's going to happen. That's okay. If it happens, it happens. But don't just say, yep, drew my 2 lines, that's where they intersect, that's what I'm going with. I'm all in on this answer. No, give yourself, take an extra 30 seconds, plug it back in, and check it. If it doesn't work, then maybe go back through and say, all right, what happened? There's something wrong. Okay? Maybe plug it in again to make sure you didn't type it in wrong if you just plug it into your calculator. Okay? But if it comes back and it sends up another red flag that, hey, this doesn't work, then you might want to see where you're at. You always have the answer here. Okay? So it's only your own self-stupidity if you do not check it and you just go with whatever you graph. Okay? Everybody's going to make a mistake sometime. I'll make a mistake whenever I graph it, and I know somebody in here will as well. But you can fix your wrong if you check it. Don't get in too big of a hurry not to try to check to see what's wrong if there is something, it is wrong. So then you do 3. All right, so you should have done 3. Did you get 0, 5?
Yeah, no, 5, 0.
What? No, it's 0, 5. I graphed it, it's 0, 5. What? I didn't do it wrong, I graphed it right. 0, 5's right. Huh? But I wrote it down. Huh? But I wrote it down as 0, 5. Huh? What did I do? How do you know? How do you know I didn't check it? Because you checked it?
Yeah.
So you're saying that 0, 5's wrong? Yeah, it's wrong. What should it be? Obviously 5, 0. Check your answer. Okay, check your answer. Plug it back in. Negative 5 plus 5 is 0. 4 times 5 minus 0 is 20. It works in both equations. Okay? If I had 0, 5, 0, 5 would have worked in the first equation, right? If I plugged in 0, 5 to here, it would have worked, right? Agreed? Yeah. What's the problem, though? It wouldn't have worked in the other one. It would have been negative 25 is equal to 20. It would have given me a red flag right here if I would have actually plugged it in. Okay? How long did it take me to actually plug it in, though? 15 seconds. It's simple math. Okay? You're not going to be dealing with a whole lot of real tough, real difficult number values here. Okay? For the most part, everything that you get as far as a solution is probably going to go in and be pretty easy to work with. So whenever we talk about the number of solutions, basically there's 3 types that you're going to get. Okay? The first one says if the graph of the system is 2 lines that intersect at one point, then the solution is going to have one solution. So if it intersects at one point, it's real simple. It's going to have one solution. If the graph, so the second one then says if the graph of the system is a single line, then the system has many, or you can say infinite solutions. Basically, it's just 2 lines that are stuck on top of each other. Okay? If it's going to have one solution, it's going to look something like that there. Okay? So that's one solution. It's going to have many solutions if I have a line and then I end up having another line that's just going to basically run right across the top of it. Okay, where I have the blue one and the red one where it's the same line. Now it says then for the third one, if the graph of the system is a pair of parallel lines, then the system's going to have no solution. Remember, if they're parallel, are they ever going to intersect? Nope. So if they're parallel, they are never going to intersect. So there can't be a value where they cross. Okay, there can't be a value that's going to work. So if they're parallel, it's not going to have a solution.